This one I think you are having a trouble. But the acceleration that you calculated was correct. Look, if m is the mass of each block, so when you add all the masses, the total mass will be, see if we are talking about this question, so total mass will be m into 3, which is 3m. Okay, so if the force is acting, the force that is acting is F. So when you're calculating the acceleration, it will be F divided by 3m. Till here, I think you were able to write it correctly. Yes?
Yes, ma'am.
Okay. See, when we're talking about this body A, so you have to see what all forces are acting on this body A. Okay. So mass of the block A is what? It's given as m. Okay, acceleration, you know, it is F by 3m. So now when you're talking about this block, there is nothing, this is one more point is that it's a frictionless block. So if it's a frictionless block, one thing makes our calculation very easier, that you don't have to consider any frictional force in this. Then how will you answer this? A block is there. How will you calculate the net acceleration on the net force on the A block? We'll say net force is equal to mass into acceleration. And right now the net force acting is F. Okay. If the net force acting is F in this case, we can see F net is equal to m times A. Now, F net on, I'll write it as F. What is the mass? Mass is m. What is the acceleration? F by 3m. mm will be cancelled. Will we get F by 3 here? Yes?
But we cannot take the F to the other side.
Which F?
Oh, no, it's FA.
Yes,
That way we
yes.
can cancel the F from the acceleration and from the other side, right hand side, left hand side.
No. We are not cancelling that. It's just that mass is there and acceleration is there. F is equal to ma for the first block. This is what we'll have. There is no other net force acting. If there was frictional force, then we would have written this as F minus small f is equal to ma. And then it would have been F minus F as ma. Then we would have solved it using mu n ma like this. But the question says frictionless. As soon as it is frictionless, calculations become very easy. You don't have to figure on anything. Force will be just the force F that is acting on this block. Did you get it, Neha, now?
Yes.
Okay. Now see, when you're talking about the block B, now this F is acting on A and B right now. When you're talking about the block B, actually in this question, see, there is one force being applied. So this is the force F. Okay, this is F force. So see, to find the force that block A applies on block B, we consider the combined masses of the blocks. Look, if I talk about this, look, I want to find out force on the block B. Okay, force that A applies on B. See, when A is applying force on B, Neha, will it just apply on B?
No.
No, it will apply on
C.
B and C both, not just C. When
Okay.
A is giving a force, so this force is coming to what? It is coming to B and C together. Yes?
Yes, ma'am.
See, what
Yes.
do you get? You just again use the equation because there is no net force, counter force to balance it. What will you get? You will again say the net force is equal to MA. Now, what's the net force that we are calculating? What's the net force that A is exerting on B? Mass. Mass will be of B and C both. This is our system right now. See, when you draw the FBD, this will be your system where a force F is being acted. Like this, you will just draw the force F and this is a body. So mass will be 2m and the acceleration we already calculated F by 3m. mm will go, that becomes 2F by 3. Got it?
Yes, ma'am.
Okay. Now see, when you're talking about this block, C, finally, when you're talking, this is 3. When you're finally talking about the last block, that is the C block. So when you're calculating the force that B applies on C, so B is applying, now see, B because it was in the middle, it was influencing C. But now forget this. See, B is applying a force on C. Let's say some F dash. So see, it's just if you draw the FBD, it will just look like this. This is a block C. A force is being applied F dash. That's it. This is how the FBD of C will be drawn.
Yes, ma'am.
So here, see, forces, the masses will keep on getting reduced. No, when this force was applied, this force influenced A, B, and C together. When you have three blocks together and you push one of the blocks, what will happen? All the three blocks will move. So to calculate that acceleration, to calculate that force, we had this concept. We were adding all the mass, right? So here F dash is there. It will become M into what is the acceleration? F by 3m. So it will also come out to be F by 3 because both are towards the edges, no? So see, when you are calculating the acceleration, it is F by 3m Neha. Net force on the block A is also F by 3. Net force that the A applies on B will be 2F by 3 because both the blocks are getting disturbed. And finally, again, now you're left with the last block. So force that B applies on C will be F by 3. So I'll just mark this is the acceleration. This is one of the forces. This is the second force. This is the fourth. Now got this, Neha?
Yes, ma'am.
Okay. Write it and see action reaction pairs. Yes, Neha. It says action reaction pairs. So action and reaction are very obvious when B is applying a force on C. An equal and opposite reaction C will also apply on B. First is that when A is applying on B, then B will also be applying a force on A. So two reaction pairs you will be able to identify. One will be this, one will be this F dash. These were the action reaction pairs.
Yes, ma'am.
Okay. Please write this, Neha.
Yes.
Okay, see Neha, this was also a question in which you had it out, 10th one.
The ninth, not 10th.
9th was correct, what you've done. That was right.
I didn't do the ninth one. I put a star in it.
No, I think you've not done the 9th one.
Yes,
You've
ma'am.
written,
10th I did.
you've added the masses of both of them.
No, ma'am. I was confused with that question, so I didn't do it.
Okay, let me discuss this then. 9th one. See, this says 10 1 rupee coins are put on the top of each other. Okay, this is actually a question from your NCRT only. This question. So 10 coins are, it's like one coin, then second coin, third coin, fourth coin, fifth coin, like this. All the coins are present. The pile of coins which we say. Okay, this is how the coins are present. It says each coin has a mass of m. Let's talk about this one. Let's say this has a mass of m. Then it says you have to find the force on the seventh coin counted from the bottom. Means this one. Third from the top. The third one from the top, seventh from the bottom means third from the top. Due to all the coins on the top. See, all the coins on the top will mean 3 mass. 3 coins will only come. 1 coin will come. Second coin will come. Third coin will come. Seventh from the bottom. So what all forces? Let's say this is the force on the seventh one. Let's say this is the seventh. 8, 9, 10. These will be left. So when we are calculating the force on the seventh, force will be one force will be due to this. One force will be due to this. One force will be due to this. These will be exerting their weight on it like this. mg. So 3 coins are there, so it becomes 3 times mg. This is the force for the first one. Second says the force on the seventh coin by the eighth one. This is the 7th, this is the 8th. See, all the 3 when it was asked, all the 3 coins, we had all the 3. But when you're talking about the 8th one, okay, see Neha. This is, let's say, the first coin, second coin, third coin, and fourth coin. From the bottom, if you calculate, this is the 7th one, this is the 8th, 9th, and 10th. Yes?
Yes, ma'am.
Okay, now see, when we are talking about now it says, what does this one, 8th one, this one is exerting the force on the 7th one. Okay, so this is there for the 7th one. What is it exerting? Now, whatever weight the 8th coin will face, it will be exerting the same force back on the 7th one. Right, whatever force it is exerting, whatever, that's why they'll form the action reaction pairs. Here, what will be the action will be the reaction. From this side, what will be the action will be the reaction. Right, so you just need to find out what's the force exerted till the 8th one. That same force will be exerted on the 7th. See, totally, this 10th one is exerting what it is, just exerting mg. What is 9th one doing? 9th one is exerting a force of 2 mg on it, right? So 8, then all the 3 will exert a force of 3 mg as we discussed. So what just about this 8th one? What only about if this only 8th one is existing then? So whatever forces it is feeling on itself, it will exert on it. So it will exert force of 2 mg. Then it says the reaction of the sixth coin on the seventh. Now when we're talking about the sixth, this is the sixth one. Okay. Sixth one will have what all forces? See, the sixth one will have the forces 4 mg due to all the 3. But what forces it is exerting on the 7th? This is the force 4 mg. 4 mg is being exerted by 6 on the 5th one. If I ask further, let's say this is the 5th one, then 4 mg is being exerted on the 5th one. Then how do I calculate the force that is coming on the 7th one? So see, you see here, if whatever forces the 7 will be exerting on 6, equal and opposite 6 will be exerting on 7. So till here you have this is mg, 2 mg, 3 mg, 4 mg, right? So it will exert a force of, it is, this 7th one is having a force of 3 mg. This look at the first one. This seventh one is having a force of 3 mg. Where is this 3 mg going? 3 mg is going towards the sixth coin. So this will exert, this sixth one will exert equal and opposite 3 mg to 7, because this is saying a reaction force, not the total force. Got it?
Yes, ma'am.
So see, for the first part, force on the seventh. Seventh coin means third from the top. Okay. So 3 coins are exerting pressure force on the seventh one. So the answer is 3 mg for the first one. I can say force on the seventh coin, but just by the eighth coin. So eighth will give a reaction force, whatever it is coming, whatever it is gaining a force of 2 mg. So this will also be 2 mg here. Then it says the reaction of the sixth on the seventh coin. Now, sixth will again give back what it is receiving. It is receiving a force of 3 mg, so it will give back the force of 3 mg. Got it?
Yes, ma'am.
Please write it. Then let's move to circular motion. Okay, see, when we are talking about the circular motion, I just started and we didn't discuss much in it. See, like you have studied the kinematics of linear motion, you will study the kinematics of circular motion. So, what is meant by the kinematics of circular motion? Likewise, your distance, displacement, velocity, acceleration, everything will come, but now in terms of circular motion. So keep it in your mind. This is all related to the circular motion. Okay. So when we're talking about the circle, if let's say a body has started, let's say this is the circular part. A body starts from this point, okay, like this, and reaches this point. So see, this is how the body will move in a circular track. So the angle, basically here what you're getting the angle that is being subtended. Here you're getting the angle. So look here, if we have this as the A point, this as the B point, this will be the angle that will be subtended. So the angle swept by the body, angle swept by the body is known as angular displacement. So this way, again, this is the displacement only. This is not a distance. So how to identify? See, this becomes your initial point. This becomes your final point. And whatever is the angle swept in between, this part, whatever is the angle that is swept in between, this becomes your angular distance. The shortest path and the longest path, that you don't have to consider here because this is all related to angles. Got it?
Yes, ma'am.
Do you remember the SI unit of angle, Neha?
Radian
Yes,
was
yes. So this is radian and symbol is RAD. Okay. Now talking about the axial vector. Axial vectors are basically those vectors where direction is associated with the axis of rotation. Like if there's a circle, fan is going. So this is the axis of the fan and the blades are moving like this across the fans. So here the direction of the vector will be given through this axis. That is known as an axial vector. When you have the vectors are grouped into one group is the polar vector, other group is the axial vector. Okay, so here the direction is along the axis. Like if I have direction, I'll get the direction here. This will be the axis. So whether this will be inwards, outwards, whatever is it, but here the direction will be given by the axis. So this is the axis of the circle, and this will determine the direction. Got it? Okay, it's very easy. You will initially think, just you have to keep few things in mind. You'll be able to understand. Please write this. I'll come to velocity then. Yeah, done. Okay. See, let's talk about the angular velocity. Like we studied about the linear velocity, that this is the rate of change of displacement. When displacement changes with respect to time, we got linear velocity. That is the usual velocity which we used to talk about. Now, see, it's the rate when you have this angular displacement getting changed with time. So we say this is the rate of change of angular displacement that is giving us the angular velocity. Angular velocity is given by this symbol omega, which is d theta over dt. See, we use this when you have the time variable. If you have a duration, you can use delta theta by delta t. So this finally makes the formula as theta divided by t. You can use it in any form. Omega will be what? This is the angular velocity. Theta, this is the change in angular displacement. And t is the change in time. So this is also an axial vector, SI unit. The radian getting divided by time, so radian per second. Now, like we had uniform and non-uniform linear velocity, you will have uniform and non-uniform angular velocities as well. So uniform angular velocity, when your magnitude and direction, both of the linear velocity are the angular displacement are constant, means equal amount of angular displacement is changing with respect to equal intervals of time. Like, see, if let's say this is a circle, this is a circular track here. Let's say this is the amount of change that occurred d theta in a time t. Then again, the next which is changing is again d theta in the time t. Then the next change is again d theta in time t. With one more thing, the direction of velocity should remain constant. Why velocity's direction should remain constant? Because the linear velocity's direction is tangential, and tangent will always change at the point. So that's why we will talk about this later. So then you will understand. This is your uniform. Now for non-uniform, here you have non-uniform. Now see if there is a small angle subtended, let's say d theta 1 in time t1. Then let's say this is the next angle d theta 2 in time t2. Then you have another d theta 3 in time t3. Then you have time t4, like this. So magnitude is also changing, direction is also changing. Now, how direction of velocity will change? Reason is that I'll tell you this in detail again, don't worry. The direction of the linear velocity is assumed to be tangential. The angular velocity will be axial, but the linear velocity would be tangential. Here also angular velocity will be axial, but the linear velocity will be tangential. In uniform, this linear velocity will not exist because if it is existing, it will just change the values. That we'll see later. Right now, we are focusing on the angular velocity. Its magnitude and direction should remain the same. Yes, if it is situated in the axis, so it will continue to be in the axis only. Okay, so this is what is meant by this. Either magnitude or the direction, or both should change with respect to the time in the non-uniform one. In the uniform one, both the magnitude and direction are. Okay, write down this. Okay. See, let's come to, there's a relationship between the linear velocity and the angular velocity. Now, when we are talking about the axial part, that is your linear, the angular velocity. But the linear velocity will always be tangential to a point. At any point, if you take, whichever point you take, the linear velocity will be tangential. Okay, now there's a relationship that combines the radius, the linear velocity, the angular velocity. So the formula is V is equal to R cross omega. You don't have to do any derivation for this. Just remember the formula. So what is the meaning of each term? V is the linear velocity. R is the radius vector. And omega is the angular velocity. Okay, so remember this relationship, and most of the time, see, the radius and omega, they'll be perpendicular to each other. So even when you expand, like if I write this as V cross R will become R omega sine theta. So look here, in most of the cases, R and omega will be perpendicular because this is along the radius and this is perpendicular to the axis. The axis will always be perpendicular to the surface. In most of the cases, you will get this angle as 90 degree. That makes this whole concept about the velocity V is equal to R omega. This is directly used, and this is often used in your angular rotation. In your chapter system of particles and rotation of motion, there also we will be dealing this. See, this says a body is moving on a circular track, completes 10 revolutions in 5 seconds. Do you get it? What is meant by this? 10 revolutions in 5 seconds. One revolution is equal to 360 degree, which we say 2 pi radian. If a person is covering 10 revolutions in radian, how much it will be, Neha?
10 into 2 pi radian.
That is 20 pi. Okay.
20
So, yes, time is 5 seconds. Radius is given as to two things you have to get, angular velocity and the linear velocity. First, let us calculate the angular velocity. See, the number of revolutions in terms of radian. Why radian? Why did I say radian? Because see, for omega, you have theta divided by t. And theta cannot be put in terms of revolutions or in terms of degrees. So 10 revolutions mean revolution like the revolution of the earth around the sun. It's a complete circular pattern covering from the initial point to the final point, making a complete 360 degree. That is what is meant by one revolution. That you already know from the planetary part. Okay. So similarly here also, one revolution, two revolution, three revolutions, four revolutions, till 10th revolutions. So how many angles are done? 360 into 360, 360 plus 360 plus 360, 10 times means 10 into 360. But that will give us the answer in the radian. And you cannot use radian for the SI part, standard part, right? So that's why we convert theta, we say theta will be equal to 2 into 10. If you have, you will just use the unitary method. That also will help. One revolution is equal to 2 pi radian. Therefore, 10 revolutions will be 10 into 2 pi radian. Theta will be 20 pi radian and time is given as 5 seconds. Yeah, time is 5 seconds. So we will get omega, value of omega. So omega will come out to be 20 pi divided by 5, which is 4 pi radian per second. This is the answer. Now coming to the velocity. The linear velocity, just use the relation r omega. Here radius is given as 2. Radius of the track is given as 2 into 4 pi. So this is in meter. So this becomes 8. But see, 8 pi, but this is not your angular, this is the linear one. So use the normal unit, meter per second, what you've studied. Linear means whatever you studied in the kinematics. Okay. All right, now write it till here. No, see, it says calculate the angular velocity of the rotation of the Earth. So in this, when we have to calculate the rotation of the Earth, we have angular velocity is formalized, displacement by time. Now, can you tell me what should be the value of theta, the angular displacement?
2 pi radian.
Yes, because that one rotation is covering 360 degree only. So this will be 2 pi radian. Now coming to the time. This is talking about the rotation. So one rotation of Earth means 24 hours, means this much of minutes, this much of seconds. Yes. So omega will be 2 pi divided by 24 into 3600 radian per second. So this value I don't remember. You can calculate and check. Okay. We'll see some other questions. Please write it.
Yes.
See, Neha, the value of theta is given as 3t square plus 2t plus 1. Now, in the first part, this says to calculate the angular velocity when a time interval is given. So when you have a time interval, you use the formula delta theta divided by delta t. Now, this means final theta minus initial theta divided by the final time minus initial time. So let's see what will be the final theta. Finally, the time is 2. So 3 into 2 square plus 2 into 2 plus 1. So this is 4, 12, 12 plus 4, 16, and this becomes 17 radian. And second is initially, theta initial will be 3 into 0 square plus 2 into 0 plus 1. That is 1 radian itself. So when omega is calculated, This is 17 minus 1 by 2 minus 0. This is 16 by 2, which is equal to 8 radian per second. The answer for the first part. Second says at t is equal to 2 seconds. Now, when you have a time instant present, this is saying that there is a time instant present. So if you have a time instant given, this means you need to differentiate to get the exact value at for the omega, you need to get the exact value at t is equal to 2 seconds. So just to substitute t is equal to 2, you need to get the equation of omega. That will be given through differentiation because as I told you, this is time instant. So 3t square becomes plus 60 plus 2 plus 0. So 60 plus 2, so I can say at t is equal to 2 seconds, omega will be 6 into 2 plus 2, that is 14 radian per second. Got it? Okay. We did these questions in the linear velocity, similar is here. Okay. Write down this one. Neha, see, when we're talking about the uniform circular motion, so when do we say a body is in uniform circular motion or a body is exhibiting a uniform circular motion? Few things have to be constant. Magnitude of the linear velocity. If this is v, at this point also it will be v. At this point also it will be v. At this point also it will be v. Let's say this is 3 meter per second. This will also be 3 meter per second, not 2.9 or 3.1. Okay. So this will be 3 meter per second. This will be 3 meter per second. This is the first condition. Second is that direction of linear velocity can change. This allowance is there because see, at every point when you're taking a tangential point, okay, this is what? This is a tangent taken. So tangent will always point differently. See, this tangent is pointing towards the right. This point tangent is pointing towards the down, means downwards. This is pointing towards the left. This is pointing upwards. So direction of tangent will change. So what you will do for the tangential direction, you cannot do anything. So that can change, but magnitude cannot change. Okay. Talking about the angular velocity, let's say at the center, the value of omega is 4 pi radian per second. So this should be throughout. This shouldn't be depending on something. It shouldn't be 4 pi t or something. And direction of angular velocity has to be the same here. If this is inwards, it will remain inwards because this changing is not possible also. But this changing is possible, which is allowed. So when you have this motion, magnitude of angular velocity is not changing, direction of angular velocity is not changing, magnitude of linear velocity is not changing, but the direction of linear velocity can change. Then we call this as a uniform circular motion. Okay. Write about it. These are the conditions. Let's write them as the conditions. Okay, please copy. Yeah. I hope you got this.
Yes, ma'am.
All right.